Uh-oh, where's my pencil? That's not good. I already started the lecture and can't find my pencil. Okay, so the metric system, all we did with dimensional analysis is change units. Lord Jesus. Okay, so what is this equal to? What? What is the rule that tells me that? Anything over itself is 1. So what is 12 inches equal? 1 foot. So is it safe to assume that 12 inches over 1 foot is also equal to 1? Yes, right? That's all we were doing in dimensional analysis, is taking something that's equal to itself, okay, so we could change units, because all we care about is changing units in dimensional analysis. Now, what about this? What would I do with the 3's? They cancel out. And that's what we're doing when I say the words on the top or the words on the bottom. We're just canceling units, because those are units we don't care about. And they just help us to get to our final answer. So let's get started. How many centimeters are in 3.25 kilometers? So I began by writing my given every time. 3.25 kilometers, the words on the top or the words on the bottom. For every 1 kilometer, how many meters is there? For every kilo, what did we learn today? How many meters? Let's make sure we're studying. There's 1,000 meters in a kilometer. Okay? So kilometers cancel, and I'm left with meters. That's not my unknown, so I got to keep going. So the words on the top or the words on the bottom, for every 1 meter, how many centimeters? 100. Remember, there's 100 years in a century, cent. So 100 pennies in $1, right? Now we just multiply across the top. Divide by the bottom. But we don't even need a calculator. This is what's so awesome about the metric system. How many zeros do I have here? Plus these 3 is? So here's my answer. 3.25 times 10 to the 5th centimeters. What? Because our meters cancel, so we're left with centimeters. Because all I'm doing is moving their decimal. And what does this mean? Move my decimal. Don't believe me? Put it in your calculator now and try it. Scientific notation, so it's 3.25 times 10 to the 5th. How many milliliters are in 5.67 liters? We start by writing the given, 5.67 liters. The words on the top or the words on the bottom. For every 1 liter, how many milliliters? 1,000 milliliters. Liters cancel. I'm left with milliliters, which is my unknown, so I stop. So how many zeros do I have here? 3. So my answer is 5.67 times 10 to the 3rd milliliters. Yep, just move. Just the order of magnitude that we learned today. Right? So this is how cool the metric system is. Now let me tell you how not cool the standard system is. How many inches are in 3.67 miles? So we began with 3.67 miles. See, aren't you proud of yourself for not giving up? A lot of people just want to give up. But just keep on practicing and things will make sense to you. So 3.67 miles, the words on the top are the words on the bottom. I have a conversion right there. For every 1 mile, there's 5,280 feet. So my miles cancel. I'm still looking for feet. The words on the top or the words on the bottom. I know for every 1 foot, there are 12 inches. So my feet cancel. I'm left with inches, which is my unknown. Now, look, I don't get to move decimals. I have to actually do math. So that's no fun. That's why I like the metric system. So we're going to put in our calculators. 3.67 times 5,280 times 12. You've got to practice this with me. Now, we get this number of 232,531. That will never be our answer. Why? Because how many significant figures do I need? Let's back up for a second. What are these two types of numbers called, or what are these numbers? Exact numbers. Exact numbers don't play a part in significant figures. It's our inexact numbers. And for my new students, that's all in your notes. My inexact numbers play a part. So it tells me I have 3 sig figs, so I need 3 sig figs here. So my answer will be 2.33 times 10 to the 5th inches, right? Because 1, 2, 3, 4, 5. I got to move my decimal 5 times. Questions? You don't get it? Right. E means times 10 to the. Where did I lose you at, babe? Okay. So have you gone over your notes with that? Okay. Significant figures. We need 3 sig figs. So remember, whole numbers are significant. So I need 3 here. Right? So I could technically round it out to 233,000 to have my 3 significant figures. But I don't do that. Everything except for temperature is in scientific notation. Okay? All right, so how many centimeters are in 3.67 miles? Let me give you a hint. I can actually take this, because notice these two are the same, right? 3.67 miles. And I know that there's 2.54 centimeters for every 1 inch. So I can actually go 2.33 times 10 to the 5th inches. For every 1 inch, there's 2.54 centimeters. Right? But I won't do that. I'll work it all the way out for you for practice, okay? So 3.67 miles. The words on the top are the words on the bottom. So for every 1 mile, how many feet are there? 5,280 feet. So I need feet to cancel. So for every 1 foot, there's 12 inches. For every 1 inch, that's exactly right. There's 2.54 centimeters. And so then multiply across the top and divide by the bottom. And what do we get? 5.92 times 10 to the 5th centimeters. If you do it this way, you'll get 5.91 times 10 to the 5th. Because we've rounded that out so much. Centimeters. Okay, and it's close enough. As long as you're within 0.01, I will count that. Any questions? This is what I was talking about with exact numbers. Base your sig figs on the given number, not on the conversion factor.
I have a question.
Sure.
So, like, for the multiplying, how do you know when to multiply or divide?
Okay, great question. Our numerators always multiply.
Mm-hmm.
Our denominators always divide.
So how do you know, like, which one to use, like, at the moment?
Because you're doing a top. 3.67 times this, times this, times this. The reason we haven't been dividing is because everything's 1.
Oh, so, like, if everything was at the bottom, then it was
Yep.
dividing. Okay.
And remember, here we multiply, multiply, multiply. Here we divide, divide, divide. Okay? And the one we're fixing to do is going to work. Okay, if you have your homework, I will take this as a bonus. If you don't have it, it's no big deal. It's not going to hurt you. You can turn it in to me tomorrow, which most students are going to do. Okay? I'll take it after class. Now, I'm going to go ahead and go over advanced dimensional analysis. Okay, so today we're not going to quite finish these notes.
Oh, wait, what is this for?
Those are just help you convert. Those are just conversions. So we're going to learn cubic conversions. We're going to learn double conversions, and then tomorrow we're going to learn percentages after our quiz. Okay? So, use the normal conversion factor, and for that factor, be sure to cube the unit and the number. Okay? So, we're going to convert 0.448 meters cubed to millimeters cubed. Okay? We start by writing the given 0.0448 meters cubed. Okay? Let's stop for a second and just ignore the cube for a second. The words on the top are so meter. I know that for every 1 meter, there's how many millimeters? 1,000. Right? Everybody with me on this one? Okay, but I don't want just a meter. I need a cubed meter. Yes? What I do to one thing, I have to do to the other. I have to put a cube here, and a cube here. And I multiply across the top and divide by the bottom. But I don't even really need to multiply, right? Because I know how many zeros do I have here? 1, 2, 3. 3 times 3 is how many zeros? 3 times 3 is 9. I got to move it, take away those 2. So my answer is going to be 4.48 times 10 to the 7th millimeters cubed. Because we had 9 minus those 2 I had to move here. Don't believe me? Try it yourself. Go ahead and do it now. Question. Okay, so let's see how we would put this in our calculator. I like to go ahead and put my 0 point so that way I know I've done it correctly. 448, okay, times 1,000, and we're going to use this caret button right here to the third. And we hit enter. And then if you feel like you need to, you can divide by, whoops, I hit the wrong button. You can divide by 1 raised to the third, but we know 1 times 1 times 1 is 1, so it's the same thing. So there's your answer, 4.48 times 10 to the 7th. Okay? Now let's do this one. An automobile engine has an internal engine volume of 286 inches cubed. What is this in liters? Well, let me give you a little bit background story for a second. Here I have this aluminum cube. It's 1 centimeter, okay? It is 1 centimeter. Does this cube have height, length? Does it have height? Does it have width? What is length times width times height? Volume. Okay? So when I multiply this, I'm cubing it, yes. So it also equals 1 milliliter. Have you ever heard of a cc? The doctor says, I'm going to give you a 10 cc shot. Yes? That's the same as 10 milliliters. Or there are 5 cc's of medication in this, you know, whatever. And so that means milliliters. They're interchangeable. Okay, so now that we have that conversion factor, now let's finish our problem. 286 inches cubed, because we always start by writing our given. The words on the top are the, okay, I know for every 1 inch, there's 2.54 centimeters. Yes? But I don't need just 1 inch, I need a cubed inch. So I cube everything. Because what I do to one thing, I do to the other. Okay? So my inches cubed cancels. Now I'm at centimeters cubed. I know, what's my conversion factor? 1 centimeter cube is equal to what? 1 milliliter. I don't have to cube these because they're equal to each other. Okay, our centimeters cubed canceled. Now I'm at milliliters. For every 1,000 milliliters, there is 1 liter. Yes? Okay, I put this 1,000 on the bottom because why? Because that's how many milliliters are equal to that 1 liter. Now, we're going to multiply here. 286 times 2.54 raised to the third. Now, on these calculators, make sure you pull that down. Make sure you pull that down. That's why I don't like these calculators. Times 1, and you hit enter. Then we're going to divide that by 1,000. And so a 286 cubed inch motor is 4.69 liters. You could also write it as 4.69 times 10 to the 0 liters. Whichever one works best for you if you want to stay in scientific notation. Questions on how to do that? Alright, so let's move over to double conversions. I'm trusting that y'all got it.
On top of the 10, is it a 0?
On top of what 10? Yeah, 0, because we're not moving the decimal any. Sometimes it is necessary to use dimensional analysis to perform double conversions. In other words, we will take a measurement that contains two units, such as density or speed, and convert both the top and bottom units to new units. The only tricky part about this type of conversion is how you start. A common mistake often made is not starting with the proper fraction. For example, 60 miles per hour is written 60 miles per hour. Not like this. Once you have set up your starting factor, change each unit one at a time. Once you have your starting factor, change each unit one at a time. It does not matter which unit you start with. So, bless you. The average speed of the orbiting space shuttle is 17,500 miles per hour. What is the speed in kilometers per second? What do we always start with? The given. 17,500 miles per 1 hour. Yes? Okay. Now, I'm going to change miles because I'm just used to the words on the top or the words on the bottom. So I know that for every 1 mile, how many kilometers are there? 1.609. Okay? So I'm at kilometers. I've got halfway there. So I can stop on my numerators. Now I got to convert to hours. Yes? Okay, so the words on the top are the, so what do I need up here? An hour. Do you know how many seconds are in an hour by any chance? 3,600. So if you don't know, a lot of people don't know that, so I'm going to skip that. Ethan, if you want to go ahead and use 3,600, you can. So 60 minutes. So that way my hours cancel. Now what am I going to put up here? Minutes. For every 1 minute, there are 60 seconds. Now my minutes cancel. I'm left with seconds. So my units are kilometers per second. So I've set it up right. So now we'll multiply, put this in our calculator. This is that question you were asking me earlier. 17,500 times what? 1.609, enter. Divided by 60, divided by 60. Notice I did not multiply, I divided, because denominator is always divide. And so we get 7.82 kilometers per second. Okay? Questions on how to do that? All right?
So you put the meters on top or
The kilometers.
on the bottom and the kilometers.
Well, because see how it did that for us. See, kilometers per second. Okay? We don't move anything around. Like if you screwed up and seconds were here and kilometers were here, you know you did something backwards. Okay? Any other questions? Okay, so the density of gold is 19,320 kilograms per meters cubed. What is the density in pounds per feet cubed? And I have a conversion. 1 pound equals 454 grams. I start by writing the given. 19,320 kilograms per meter cubed. Yes? Okay. You can put a 1. You don't have to. It's understood. If the number's not there, it's understood as 1. So the words on the top are the words on the bottom. So I'm going to put kilogram here. I know for every 1 kilogram, there are 1,000 grams. Yes? And it tells me here's my conversion, so I know I'm trying to get to grams. So kilograms canceled. So the words on the top are the words on the bottom. For every 454 grams, there's 1 pound, which there is my unknown for the numerator. Okay, so now I've got to get rid of my meters cubed and turn it into feet cubed. So the words on the top are the words on the bottom. For every 1 meter cubed, I have a conversions back here. What is my conversion? I have 39.37 inches. You see that? .37 inches. But I've got to cube it, yes? You with me? Okay, so then I've got to get my meters cubed cancels. I've got to get inches to what? Feet. So for every 12 inches cubed, since that's cubed, what I have to do this 12? Cube it. There is 1 foot cubed. Okay? So our inches cubed cancels. Our grams have canceled, so I've just got feet at the bottom. So I know I've set it up right. Now let's put it in our calculator. So I have 19,320 times 1,000. Whoops. Times 1,000 times 1 times 1 times 12 raised to the 3, 12 cubed. We hit enter. We're going to divide by 454. We're going to divide by 39.37 raised to the 3rd. And you hit enter. So my answer is, you got this in the calculator, but what does my answer need to be? How many significant figures? 4 sig figs. So I'm going to have 1.205 times, oops, I'm running out of room, 10 to the 3rd, because I moved my decimal 1, 2, 3 times, pounds per feet cubed. Put that in your calculator, okay? All right, one more and then we're done. The silica gel, which is used to protect sealed overseas shipments from moisture seepage, has a surface area of 6.0 times 10 to the 5th meters squared per kilogram. What is the surface in feet squared per gram? How do we start? Write the given. 6.0 times 10 to the 5th meters squared per kilogram. So, I got to get to feet. Remember my conversion from meters to inches? What is it? 1 meter squared is going to be 39.37 inches squared, yes? And we just have to square everything. Okay? So, I'm trying to get to feet, so I know that 12 inches squared is equal to 1 foot squared. Okay, so there's my foot squared. Now I got to go to grams because inches canceled. So kilograms was on the bottom. So for every 1 kilogram, there are 1,000 grams. And there's my unknown. So we just multiply across the top and divide by the bottom. 6, remember to put this in our calculator, we use this big E. 6e to the 5. 6e to the 5 times 39.37 squared, yes, times 1 times 1, we hit enter, divided by 12 squared, divided by 1,000. And so our answer, we need just 2 sig figs here, so my answer is going to be 6.5 times 10 to the 3rd feet squared per gram.